let's bring back the definition of a limit, but the way they're going to do this on the AP test is they're going to want to trick you into thinking you're going to have to evaluate this crazy limit by, extending the 3 plus h cubed 3 times and simplifying all that stuff, but you really don't have to. If you recognize it's the derivative of a function, you can just simply take that derivative. How do you know it's the derivative? Well, look, there's an h on the bottom, kind of an obvious indicator of that definition right here. Also, the whole plus h thing going on and h going to 0. This is pretty obviously a derivative. So if you write down that definition, and I'm going to use the f prime at t version, meaning we're plugging in a particular value for t. And that's going to make more sense for these. So what do you think t would be? If you look at this, just kind of guess t plus h, right? 3 plus h. You can see that as the inner function, right? So what do you think t is going to be? T is probably 3. So we're taking the derivative at 3. Now what do you think f of x is? What do you think f of t is? Well, I'm going to guess that f of t would be this 8 times t cubed. Think about that. That would make sense, right? And if t was 3, then f of 3 would be 8 times 3 cubed, which we determined that t is 3, right? So we're probably finding the derivative of 8x cubed, or 8t cubed, same idea. And so you can kind of ignore that part. Remember, it's minus f of t, right? And you can see that same form there. So we're going to find the derivative of f of t, but we want to find it when x is 3. So we want to find f prime of 3. And instead of t, you can think of that as x, but let's find f prime of x, or f prime of t. Just treat it like it's an x. That becomes 24t squared. So then f prime of 3 is 24 times 3 squared, which is 24 times 9, which is some big number. Let me think. That would be 180 plus 36. 216, I'm guessing. Let me just double check that. Man, I'm getting better at mental math. So, similar idea. On this one, you can kind of look at this function and go, hey, my f of x is probably 6 square root of x, and I need to find f prime at 9. I think about it. 6 square root of 9. You can see the 9 plus h is kind of the giveaway that we're going to evaluate at 9. So the rest of it's probably the function. And remember, the whole formula is f of, it would be f of t plus h minus f of t, where t is going to be 9. You can see the 9 plus h, right? So t is going to be 9. So our function is going to be this part here. Just replace that 9 with the variable. So let's find f prime of x. I'm just not using t this time. It just makes more sense to me to use f of x. It doesn't really matter. It still would end up with the same answer. So that's going to be 3x to the negative 1/2, which is 3 over the square root of x. All right. So f prime of 9 would equal 3 over the square root of 9, which is 1. And that's the idea there. This one, it's pretty obvious. Our function this time is 4 sine of x. I don't know why I put sine g. Sine of seeing is what that said. So 4 sine of x, and we're going to find the derivative at pi over 2. You could just see it there, right? Pi over 2 plus h is a giveaway. So pi over 2 is where we're evaluating at, and then the rest of it's our function, 4 sine. So f prime of x is going to be 4 cosine of x. So then f prime of pi over 2, if you're in pre-calc, just plug that into Desmos, make sure you're in radians. And if you're in calc, use the unit circle. 4 times pi over 2, 4 times 0 is 0. And so the last one, you can see the whole 2 plus h. Once again, give away that we're evaluating at 2. So our function will be 5 over x squared. That's a good guess there, 5 over x squared. And we want to evaluate this at 2. So f of x is 5x to the negative 2. So f prime of x will be negative 10x to the negative 3, which is negative 10 over x cubed. So what is f prime of 2? F prime of 2 is going to be negative 10 over 2 cubed. Negative 10 over 8. Simplifying is optional unless it's multiple choice. That would be negative 5 over 4. And that's disguised derivative. So you have to just look through the function and figure out, hey, how does it fit this mold here? What's your function? Take the derivative using the shortcut so you don't have to go through the long way, and then evaluate it.